Okay, today we start remaining part of the solutions. Solutions. We have completed types of solutions, Raoult's law, Henry law, colligative property, 4 types of colligative property, and last one is your osmotic pressures. Osmotic pressure. You know osmotic pressures denoted by pi. Okay. So depending upon the osmotic pressures, solutions are again classified as follows. Number one is your isotonic solution. Isotonic solution. Isotonic solutions means when two solutions have same osmotic pressures. Such solutions are known as isotonic solution. Example: 0.9 gram of sodium chloride in 100 ml of water and bloods in our vein have same osmotic pressures. So these solutions are isotonic solution. Example of isotonic solution is normal saline. Okay, normal saline means 0.9 gram of sodium chloride in 100 ml of water is a normal saline, which is used in hospitals. You have seen the drips, I think. So in drips there is a normal salines. So normal salines means 100 ml of water, 0.9 gram of sodium chloride common salts in 100 ml of water and blood. Our blood is also solutions, types of solutions, and 0.9 gram of sodium chloride in water is also solutions. These two solutions have same osmotic pressures, which is used in the use in the drips. Okay. Number two is your hypertonic solution. Hypertonic solution means hyper means if one solutions has higher osmotic pressures than another solution is known as hypertonic solution. Okay, hypertonic solutions. Hypertonic solutions. Hypertonic solutions. What happens in the hypertonic solution is the movement of particles from higher concentration to lower concentration. In this case, hyper means concentration of one solution is higher than the another solution. So higher concentration means it has higher osmotic pressures as compared to another solutions. So movement of particles from higher concentration to lower concentration takes place in the hypertonic solutions. Okay, such solutions have different osmotic pressures, or you can say one solutions have higher osmotic pressures than another osmotic pressures, another osmotic pressures of solutions. Okay, number 3 is your hypotonic solution. Hypotonic solutions means solutions which has lower osmotic pressures, lower osmotic pressures than another other solution. Such solution is known as hypotonic solution. Hypotonic solutions. Okay, it's just opposite to the hypertonic solution. Hypo means lower, hyper means higher osmotic pressure solution to the another solutions. Hypo means lower osmotic pressures to the another solution. Such solution is known as hypotonic solutions. Okay, next topic we have to osmosis, reverse osmosis. Reverse osmosis. Okay, reverse osmosis. We have studied osmosis. Okay, now it is reverse osmosis. Reverse osmosis means what happened in the reverse osmosis means in reverse osmosis there is a, in this case this is a just example. Reverse osmosis used in the water purification. Water purification is an example of reverse osmosis. In water purification, what happens? Fresh water and there is a salt water. Okay, so movement takes place from movement of water which is mixtures with salt solutions. From salt solutions, water move from salt solution to fresh water through semi-permeable membrane. Okay, semi-permeable membrane. Through semi-permeable membrane, movement of solvent from solutions to the solvents. Okay, pure solvent, that is fresh water is a pure solvent, and this is a solutions. Salt water is a movement of solvent from salt solutions to the fresh water is a reverse osmosis. Okay, so which is used in the purifications of water. We cannot drink the salt water, so we need fresh water. How to make fresh water from salt water? Then through the reverse osmosis, movement of solvent from solutions to the solvent site is a reverse osmosis. Okay, in this case, what pressure is higher than osmotic pressures. Okay, then it is a reverse osmosis. So reverse osmosis occurs when a pressure larger than the osmotic pressure is applied to the solutions. Okay, so applied pressure is larger than the osmotic pressure, then the reverse osmosis takes place. Okay, which is used in the purifications of water. Saline water, you have studied saline water, which contain sodium chloride solutions. 0.2% of sodium chloride present in the seawater, and seawater can be purified through the reverse osmosis. In reverse osmosis, what happens? Salt water, from the salt water, solvent or water move towards the fresh waters. So from this reverse osmosis, water can be purified. Okay, this is a reverse osmosis. You can make notes also. Next is your now we have to study 4 types of colligative properties. Okay, 4 colligative properties. From 4 colligative properties, first one is your elevation of boiling temperature, relative lowering of vapor pressure, relative lowering of vapor pressures. Next is your elevation of boiling temperatures. Next one is your depression of freezing point, freezing temperatures, and last one is your osmotic pressures. From all these colligative property, why these are colligative property? You know, colligative property means depending upon the M2. All these are depend upon the M2. Okay, M2. So relative lowering of vapor pressures which depend upon the M2. You know the equations. So all these are colligative property. Now if the molecular masses changes, molecular masses of solute one change, then the relative all these colligative property will be changed. Such behavior is observed in molar masses. Okay, such molar mass is known as abnormal molar mass. Okay, abnormal molar mass. When molar masses is changed, then relative lowering of vapor pressure will change, elevation of boiling temperature will change, depression of freezing point change, osmotic pressure change, because all these are depend upon the M2. When M2 change means these all properties, colligative properties will change. So example, KCl, this is a potassium chloride, potassium chloride. Okay, abnormal molar mass observed by the behavior of a solutes. Okay, so when solute undergo association due to association, the molecular mass will change, and due to dissociation. For example, potassium chloride when dissolved in water, what happen? Then K plus Cl minus will form. This is a dissociation. Dissociation occurred in this case. Molecular mass of potassium chloride is 74.5 grams. 74.5 grams. If this salts dissolve in water, then it will dissociate into K plus Cl minus, because this is a like solute which is dissolving like solvent, that is water, like dissolving like, you know. So potassium chlorides undergo a dissociations which gives different molecular mass. Different molecular mass means change in the molecular mass, because potassiums, you know, molecular mass of potassium is 39 and molecular mass of this chloride is 35.5, and the total molecular mass is 74.5 gram. When this salt associated into chloride, potassium ion and chloride ion, in that conditions molecular mass will change, because 39 grams per mole and 35.5 grams of gram per mole will form. On that conditions, this colligative property will change. So such behavior is observed by the abnormal molar mass because of the dissociation and associations. Similarly, benzoic acid, benzoic acids, you know formula C6H5COOH. These salts also change its molecular masses because of the associations. Okay, associations occurs due to the hydrogen bonding. You know formula of C6 H5C double bond O, single bond O, H, okay, dot 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 dot, dot H O, H O double bond, single bond O, double bond O, dot 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 C6H5. Due to the association, molecular mass of benzoic acid will change. Okay, similarly acetic acids, it exists in the dimeric form, where one molecule gives molecular mass will doubled, one molecular mass into two molecular mass because of these dimerizations. In that conditions, okay, due to associations, the benzoic acid shows another molecular mass, that is a abnormal molar mass, which change the colligative properties. So to determine the abnormal molar mass, Bandt factors factor I, which is denoted by I, gives the measurements, experimental measurements for the dissociation and associations of a solutes. Okay, what is Bandt factor? Okay, it is the ratio of the experimental value of colligative property to the calculated value of the colligative properties. Okay, so it is denoted by I, expressed as I. Bandt factor I is equals to normal molar mass. Normal molar mass means calculated from the colligative property. Okay, calculated from the colligative property, normal molar mass divided by observed molar mass. Observed molar mass means it is a abnormal molar mass. Okay, abnormal molar mass, when abnormal molar mass is formed due to association or dissociations. Due to association or dissociations, molar mass of such solutes will change. In that conditions, colligative property will change. Okay, similarly, observed I equals to Bandt factor observed molar mass, that is observed I Bandt factor equals to observed colligative property, that is abnormal colligative property, you can say, divided by calculated colligative property. Why this is inverted to this? From these two equations, you can, from these two expressions you have seen, in this case normal molar mass divided by observed molar mass, which is abnormal. In second case expression is invert, observed colligative property divided by calculated colligative property. Okay, you can go through expressions of one colligative property, like relative lowering of vapor pressures, in relative lowering of vapor pressures, your expressions is like P naught P1 divided by P1 naught is equals to I into N2 by N1. This is a Bantoff factor I. Okay, N2 means, you know, this is x2. Okay, P1 naught, P1 divided by P1 naught equals to I into x2. This equation can written as I into N2 by N1. Okay, N2 means in these conditions you have M2 here. Okay, M2 will be changed. So M2, why M2 change? Because of the associations or dissociations. So in that conditions, colligative property will change. So which is denoted by I. Okay, which is denoted by I. Okay, in these conditions you have seen the invert case, because colligative property is inversely proportional to the molar masses. Actually, molar masses, that means molar masses of solute, higher molar masses of solute means lower colligative property, lower colligative property means higher molar mass. This is invert cases, it's inverse cases. So normal molar mass divided by observed molar mass, observed colligative property divided by calculated colligative property. What happens when association and dissociations in the solutes? In association, what happen? In associations, what happen? In association, observed molar mass being more than the normal. Okay, observed molar mass being more than normal molar mass. In that condition, I is less than, in association condition 1, these are conditions. In associations, okay, observed molar mass being more than the normal molar mass. So के हुन्छ, Bantoff factor I has a value less than 1, because this is a ratio. Actually I is ratio, so I is lesser than 1. So in association I is lesser than 1 means molar mass is higher. Okay, take example of chlorine, Cl minus. Chloride ion have a molecular mass of 35.5 gram. Okay, when in this chlorine, this chloride ion undergo association, so it forms Cl2. Okay, Cl2 means molecular mass will 71 grams per mole. So molecular mass is higher, more than the normal molar mass. So Bantoff factor will change. In that conditions, Bantoff factor is lower than the 1. Okay, similarly number 2 conditions, in dissociation what happen? In dissociation observed molar mass being more than normal molar mass. Okay, in dissociation observed molar mass being lesser than the normal molar mass. So in that conditions I is greater than 1. Okay, I is greater than 1. Example, you can say example of potassium chlorides, okay, sodium chlorides, okay, magnesium sulfates. These are the example of salts which undergo dissociation, dissociate into K plus Cl minus, sodium plus chloride ion, similarly magnesium plus sulfide ion, so undergo dissociation. These all are undergo dissociation. In that conditions, what happen? Observed molar mass being lesser than the normal molar mass, because normal molar mass of potassium chloride, I have already explained you. Normal molar mass of potassium chloride is 74.5 grams. Now what happened? The observed molar mass, due to the dissociations, molar mass will change, so colligative property will change, or colligative property will rise by 1, so by 1 ratio, so I is greater than 1. Okay, these are the colligative properties depending upon the band of factors. Okay, so for colligative property, modifications form of colligative properties are explained. I will explain modified forms of colligative properties due to the band of factors are as follows: due to association or dissociations. Okay, number one is your relative lowering of vapor pressures. In that conditions, what happen? P1 naught minus P1 divided by P1 naught is equals to I into X2. Okay, or you can write del P divided by P naught equals to I into N2 by N1. I have changed this. Okay, and you can write del P because of the change in the pressures. Okay, this is a modified form of colligative properties. Relative lowering of vapor pressure has been changed by the I. Next, number 2, elevation of boiling point of boiling points. Elevation of boiling points, you know the equation, del TB equals to KB into M. Okay, now you can write del TB equals to I into KB into M. Okay, number 3, colligative property. Okay, number 3, colligative depression in freezing point. Depression in freezing point, that is del TF equals to I into KF into M. Okay, band of factor, you have to apply band of factor because of the association or dissociations, molecular mass of solid will change. Number 4 is your osmotic pressures. Osmotic pressures, you know equations, pi equals to I into C into R into T. Okay, or you can write osmotic equations of osmotic pressures, I into N2 into RT by V. Okay, RT by V. N2 means your number of moles of solutes by volume, because in these conditions osmotic pressures is the colligative property in which the molarity is used, not molality. Okay, so these are the 4 colligative properties.